Okay, so here's another approximation example. This is one we may have looked at in class, but I'm going to change it up. Um, Instead of using a right Riemann sum, as this says, we're going to use what's called a trapezoidal sum. So it's not really Riemann anymore because they're not rectangles, they're trapezoid. So a trapezoidal sum um, to approximate the integral. So first of all, this table gives the rate at which cars exit a freeway. It's a rate, that's key. The question is approximate the total number of cars. So when you want to go from a rate to a total amount, you integrate because if you think of it, a rate is a derivative. So if you want to undo a rate, undo a derivative, you integrate, and then you'll get the total amount. So given a rate and asked to approximate a total number, you're going to have to integrate that rate to get the total number. Now, the limits would be, well, it depends during which interval we want to get the total number, and it's saying during the 30 minutes. So this is how you would find the total number of cars that left a highway given this table of rates. Now, we don't have the actual function, so we're going to have to approximate this integral. And we're going to use trapezoidal sums because it's telling us to with 6 subintervals. So actually all the subintervals, and 0 to 5 is the first, 5 to 10 is the second, and so on. So we're going to actually form trapezoids. And I'm going to do this with the shortcut method, but I just want to show you the first trapezoid so you can visualize what I'm doing. The first trapezoid in the first interval, I'm going to look at this. T would be the x-axis, so we're going from 0 to 5. At 0, the height is 26, so let's make this 26. At 5, the height is 40. Let's make this 40. It is a trapezoid, so a trapezoid is 1/2 times the height. Now this is a trapezoid on its side, so the height is 5, times the sum of the bases. The bases are the heights, because this is a trapezoid on its side. So I could calculate this, and let me calculate it quickly. 26 plus 40 divided by 2 times 5. That's 165. So that would be the area of this trapezoid. I'm going to do the rest exactly the same. So I have 6 calculations. Now here's what I have going for me. I'm going to add all those calculations together, but they all have a height of 5 because the time is equally spaced, 5 to 10 to 15. So I can make this a little bit easier on myself by just factoring out the 1/2 times the 5, because they'll all have 1/2 times 5. So let's just make this 5/2 then. Now the first trapezoid, we're going to add up the bases. 26 plus 40. And then we're on the second trapezoid. So we already have the 1/2 times 5. You add up the bases, 40 plus 51. So let's just make this the next trapezoid. The heights will be the third trapezoid, 51 plus 47. So another 51 plus 47. Next trapezoid, fourth, its height would be first height would be 47 and then 33. So you can kind of see the pattern going here. If you're more comfortable, draw all the trapezoids. You can't miss. Oops. screwed that up. So I don't know what I was talking. I guess so let me say that again. The fourth is 47 plus 33. So again, hopefully you can see the pattern. Next is 33 plus 20. And the last is 20. So two of those plus 15. And we're done. So you can see that 15 is going to be used once because it's only part of one trapezoid. So is a 26. Every other height was used twice. Now you can only do this really if you have equal intervals. Otherwise, you would have to just do all of them separately like I was doing over here. So hopefully that made sense. I'm going to calculate this. 26 plus 80 plus 102. Hopefully I do this right. 2 times 47 plus 66 plus 40 plus 15. So no guarantees here, but I am getting 1,057.5. And that's the number of cars that exited the highway during these 30 minutes. And that's it.